Hello dear learners, I am Dr. Geraldina Fernandez, Associate Professor from the Department of Mathematics and Statistics, the Bhopal School of Social Sciences. Dear learners, in the last few lectures, I have discussed about linear differential equations and Bernoulli differential equations and the steps involved to solve such kind of differential equations. So now, in this module, I will be discussing about a very important topic of calculus, that is exact differential equation, which is another form of first order differential equation. So before moving on, let's first have a look at the topics that will be covered in today's lecture. So in today's lecture, we will be discussing about the definition of exact differential equation, the condition, that is the minimum, that is the necessary and sufficient condition for a differential equation to be exact. So we will discuss the condition of exactness. Next, we will discuss the steps that are involved or the method for solving exact differential equations. And last but not the least, we will practice some questions to have a better understanding of the topic. So what is exact differential equation? A differential equation is called exact differential equation if it can be derived from its primitive, which is also known as solution, directly by differentiating without any subsequent operation of elimination or reduction, etc. So by this we mean that only those differential equations will be called as exact differential equations if they can be derived from their solution with the help of differentiation, and we will not use any other subsequent operation of elimination or reduction. So those equations will be called as exact differential equations, or we can say those equations which are not separable. I mean, we cannot separate the variables and then integrate. So for those equations, we will use the following method. So in other words, the differential equation, the standard form is m dx plus n dy is equal to 0, is exact if there exists a function u of x comma y such that the total differential of u is given by the formula du is equal to del u by del x dx plus del u by del y dy, which is nothing but m dx plus n dy. So here we can say that a differential equation can be exact if it can be derived from its solution without any other operation. So now let's have a look at the example of exact differential equation. So the equation x square dx minus y square dy is equal to 0. So this is a differential equation. Now this differential equation is called as a exact differential equation. Why? Because it can be obtained from its solution. Now the question is how? So we can solve it. Here this is a differential equation. You can see that x square dx minus y square dy equal to 0 is a differential equation. So what we will do, here we will separate the variables. So we can write it as x square dx is equal to y square dy. So here the variables are separated. Simply you have to integrate and find the solution of the given differential equation. So what we can do, we can write by using the power rule, integration of x square will become x cube by 3, integration of y square will become y cube by 3, and plus since we are dealing with indefinite integrals, so we will have to add the constant of integration. So shifting the function to the left hand side, we have x cube by 3 minus y cube by 3 is equal to c1. So while taking the LCM, we will have 3. In the numerator, we will have x cube minus y cube by 3 is equal to c. So shifting this 3 to the right hand side, we will have x cube minus y cube is equal to 3c. Again 3c is a constant, we can write it as c1. Say for example, we take it as c1. So this is the solution of the given differential equation. Now if by simply differentiating we get the same original differential equation, so then the differential equation can be called as exact differential equation. So initially it is a differential equation, but only those differential equations which can be obtained from their solution by simply differentiating will be called as exact differential equation. So here we have the solution. Now by simply differentiating it with respect to x on both sides. Here we are differentiating x cube minus y cube is equal to c1. 3c can be substituted by c1. c1 is also constant. So, here we are differentiating it with respect to x on both sides. So, differentiation of x cube will become 3x square minus differentiation of y cube will become 3y square into dy by dx by chain rule, and differentiation of c1 is 0. So, by simplifying it, what we will get? We can take 3 common and we will have x square dx minus y square dy is equal to 0. So, shift 3 to the other side, we have x square dx minus y square dy is equal to 0, which is the same equation that we have discussed. So, since this can be derived from its solution, therefore, the given differential equation is an exact differential equation. So, this is the solution, this is the example of exact differential equation. Now, next is we will discuss the condition, the necessary and sufficient condition for exactness of first order differential equation. So, what is the condition? So, the necessary and sufficient condition that the ordinary differential equation m dx, we can take this one, m dx plus n dy equal to 0, to be exact is del m by del y is equal to del n by del x. So, if any differential equation has to be exact, then it should satisfy the condition, that is the partial differentiation of m with respect to y should be equal to the partial differentiation of n with respect to x, that is del m upon del y should be equal to del n upon del x. Then only the given differential equation can be called as an exact differential equation. So, this is the very important condition. Next, now we will discuss the steps that are involved. First, we have found out that the given differential equation is exact. Now, the next step is that you will have to find the solution of the given exact differential equation, which is of the form m dx plus n dy is equal to 0. So, step number 1 is that you have to write the given differential equation in the standard form. So, the standard form is m dx plus n dy is equal to 0. So, write the given differential equation in this form. This is step number 1. Step number 2 is you will have to check the exactness, that is after finding out the value of m and n, the value of m is the coefficient of dx and the value of n is the coefficient of dy. So, after finding out the value of m and n, you will have to check the exactness. So, the exactness will be checked by that you will have to differentiate m with respect to y partially, treating x as constant, and differentiate n with respect to x partially, treating y as constant, and if they appear to be equal, the values of both the derivatives, if they are equal, then we say that the given differential equation is exact. Now, the last step is that you have to find the solution or the general solution of the given differential equation, which is exact. So, this formula is given by integration of m dx, here we treat y as constant, and integration of n, and we will write the terms which are free from x over here. So, only those terms of n will be considered which are free from x, and we will integrate it with respect to y, treating x as constant, and that is equal to c, where c is the constant of integration. So, the general solution is given by the formula integration of m dx treating y as constant plus integration of n where terms are free from x, we will integrate it with respect to y, treating x as constant. To have a better understanding of the topic, let us practice few questions. So, question number 1 is solve y e raised to the power x dx plus 2y plus e raised to the power x dy is equal to 0. So, this is a first order differential equation. We can see that here the variables cannot be separated. So, we will solve it by the following method that we have discussed just now. So, first step is we will write the given differential equation, that is y e raised to the power x dx plus 2y plus e raised to the power x dy is equal to 0. So, we will mark this differential equation as 1. Now, you can compare this differential equation with the standard exact differential equation, that is m dx plus n dy is equal to 0. So, this is the standard exact differential equation. We will compare this standard differential equation with our question. So we can clearly see that the value of m is the coefficient of dy. So here capital M is the coefficient of dx, that is y e raised to the power x, and the coefficient of dy is 2y plus e raised to the power x. So we can see that the coefficient of dx is m and the coefficient of dy is n. So we have compared it and got the values of m and n. Now this was the first step. Second step is you have to differentiate m with respect to y and differentiate n with respect to x. So we have to differentiate m with respect to y and differentiate n with respect to x. So while differentiating m, we can write it as del upon del y of y e raised to the power x. So you can see here we have to partially differentiate the given function with respect to y. So since we are partially differentiating the function, e raised to the power x will be treated as constant and differentiation of y with respect to y is 1. So the value of del m by del y is e raised to the power x. Now we will differentiate n with respect to x. So the value of n is 2y plus e raised to the power x. So we will differentiate the given function with respect to x. So here we will use the rule of differentiation, that is the derivative of the sum of two functions will be equal to the sum of the derivative of the two functions. So that is the sum of the derivative of the two functions. Now for the first term you can see we are having 2y and we have to differentiate this function with respect to x partially. So treating y as constant, differentiation with respect to x will give us 0 and differentiation of e raised to the power x with respect to x is e raised to the power x. So finally the value of del n up by del x is e raised to the power x, which is same as the value of del m upon del y. So we can clearly see that del m upon del y is equal to del n by del x. So we will write here clearly del m by del y is equal to del n by del x. Therefore, equation number 1 is exact. So first step was to find the value of m and n. Second step was to differentiate m with respect to y and n with respect to x. Now we have found out that del m upon del y is equal to del n upon del x. So equation 1 is exact. So next step is to find the solution of equation number 1. So solution of equation number 1 is given by, here the formula is integration of m dx treating y as constant plus integration of n, the terms that are free from x. We will only consider those terms of n which are free from terms free from x is equal to c. So here the value of m is what? The value of m is y e raised to the power x. So we will substitute the value of m. So the value of m is y e raised to the power x and we have to treat y as constant while integrating it with respect to x, plus now we will consider only those terms of n which are free from x. So here n is what? Here n is 2y plus e raised to the power x. So out of these two terms we will consider only the term which is free from x. So we can see that here e raised to the power x is having a function of x, but for the first term 2y, this is free from x. So the value of n will be just 2y dy, here we are missing out dy. So 2y dy is equal to c. So since y is treated as constant, integration of e raised to the power x will be e raised to the power x. So here y is treated as constant, so integration of e raised to the power x is e raised to the power x plus 2 can be taken out of the integration, and integration of y with the help of power rule will be 2 times y square by 2, that is equal to c. So, we can simplify this and have y e raised to the power x plus y square is equal to c as the solution of the exact differential equation. So, this was question number 1. So, next question number 2 is you have to solve 1 plus 4xy plus 2y square into dx plus 1 plus 4xy plus 2x square dy is equal to 0. So, we can clearly see that this differential equation is of first order, but here the variables cannot be separated. So, we will use this new method to solve the following differential equation. Step 1 is to write the given differential equation. So, given 1 plus 4xy plus 2y square dx plus 1 plus 4xy plus 2x square into dy is equal to 0. So, we will mark this as equation number 1. Next step is you will have to compare the given differential equation with the standard exact differential equation. So, m dx plus n dy is equal to 0. This is the standard exact differential equation. So, what we will do, we will find the coefficient of dx, that will be m, and the coefficient of dy, that will be n. So, here the coefficient of dx is, this is the coefficient of dx which will be taken as m, and this is the coefficient of dy that will be taken as n. So, here m is the coefficient of dx, that is 1 plus 4xy plus 2y square, and the value of n is 1 plus 4xy plus 2x square. So, this was step number 1. First step was to write the given differential equation and find out the value of m and n. Now, the second step is that you have to partially differentiate m with respect to y, and simultaneously you have to differentiate n with respect to x. So, here we have to differentiate m with respect to y. So, that is 1 plus 4xy plus 2y square. Again, we will use the rule of differentiation, that is the derivative of sum of 3 functions will be equal to the sum of the derivative of the functions. So, this will become del by del y of 1 plus del by del y of 4xy plus del by del y of 2y square. So, this we will solve after some time. So, now differentiation of 1. Differentiation of 1 is a constant with respect to y, will give us 0 plus differentiation of 4xy with respect to y. So, here 4 and x can be treated as constant with respect to y, and differentiation of y with respect to y will be 1 plus differentiation of 2y square with respect to y will be 4y. So, here the value of del m upon del y is 4x plus 4y. So, this is the value of del m upon del y. Next step is to find the value of del n by del x. So, I can write it again, that the value of n is equal to 1 plus 4xy plus 2x square. So, this is n. Now, we will differentiate n with respect to x. So, we will get del by del x of 1 plus 4xy plus 2x square. Again, using the rule of differentiation, that is the derivative of sum of 3 functions will be equal to the sum of the derivative of the function. So, del by del x of the second term is 4xy plus del upon del x of 2x square. So, again differentiation of a constant with respect to x will be 0. Then differentiation of 4xy with respect to x. So, here 4y can be treated as constant, and differentiation of x with respect to x is 1 plus differentiation of 2x square with respect to x by power rule can be written as 4x. So, del n by del x, the value is 4y plus 4x, which is similar to the value of del m upon del y. So, clearly we can write that del m by del y is equal to del n by del x. So, which is the condition of exactness? So, this is the condition of exactness. So, we can say that equation number 1 is exact. So, therefore, equation 1 is exact. Now, we need to find the solution of this exact differential equation. So, the solution of exact differential equation, solution of equation number 1 is given by the formula integration of m dx treating y as constant plus integration of n, and n will have only those terms which are free from x. dy is equal to c, where c is a constant of integration. So, first step is to put the value of m as it is. So, that is 1 plus 4xy plus of we have 2y square plus of 2y square plus 2y square into dx, plus we will consider only those terms of n which are free from x. So, only those terms of n which are free from x. So, here n has 3 terms. This is the first term, this is the second term, and that is the third term. So, we have to select only that part which is free from x. So, this is not free from x, this is also not free from x as it has x in 4xy, but this term is free from x. So, we will write 1 in place of n, we will put the value of n as 1. So, this is 1 dy is equal to c. Now, simply you have to integrate with respect to x and with respect to y. So, integration of 1, we will separate each and every term. So, integration of 1 dx, integration of 4xy dx plus integration of 2y square dx plus integration of 1 dy is equal to c. So, integration of 1 with respect to x will be x plus, since we are integrating with respect to x, 4y is treated as constant, and integration of x by power rule will be x square by 2 plus, here we are again integrating with respect to x, so 2y square will be treated as constant, and integration of 1 with respect to x will be x plus integration of 1 with respect to y will be y is equal to c. So, last step is we can simplify. So, here we can simplify and that is it. So, the value or the solution of the exact differential equation is, I can write it here, x square plus 2 plus 2yx square plus 2x square y plus y is equal to c. So, this is the solution of the exact differential equation. So, this is question number 2. Now, the last question is solve 1 plus e raised to the power x by y dx plus e raised to the power x by y multiplied by 1 minus x by y dy is equal to 0. So, here the differential equation is of first order and we cannot separate the variables easily for integration. So, we will have to use the following method. Step 1 is to write the given differential equation, that is 1 plus e raised to the power x by y dx plus e raised to the power x by y 1 minus x by y dy is equal to 0. We will mark this as equation number 1. Now, first step is you will have to check whether the given differential equation is exact or not, and the second step is then you have to find the solution of this exact differential equation. So, first step is to compare it with the standard exact differential equation, that is m dx plus n dy is equal to 0. So, this is the standard exact differential equation. So, the coefficient of dx is m and the coefficient of dy is n. So, here the coefficient of dx is m, that is 1 plus e raised to the power x by y, and the coefficient of dy is taken as n. So, here the coefficient of dy is e raised to the power x by y 1 into 1 minus x by y. So, this was the first step. Now the second step is that you will have to check the exactness of the given differential equation number 1. So that we can do by differentiating m with respect to y on both sides. So del by del y of 1 plus e raised to the power x by y. Now this derivative will get multiplied with the terms. So del by del y of e raised to the power x by y. So differentiation of a constant with respect to a variable y is 0, plus since here the function, exponential function has y in it, so we have to differentiate the given function with respect to y, so that is possible. So in differentiation of exponential function is the function itself multiplied by, we will have to use the chain rule, so multiplied by del y of x by y. So the first term is 0, and for the second term we will have e raised to the power x by y as it is, multiplied by differentiation of x by y with respect to, partially with respect to y. So here x is treated as constant with respect to y, and differentiation of 1 upon y is minus 1 upon y square. So the final value of del m upon del y is minus x by y e raised to the power y square e raised to the power x by y. So this is the value of del m upon del y, e raised to the power x by y, yes, and minus of x by y square. And next step is that you will have to differentiate n with respect to x. So the value of n was e raised to the power x by y multiplied by 1 minus x by y. So this is the value of n. See, this is the value of n. So we are differentiating n both sides with respect to x to check whether the given differential equation 1 is exact or not. So here, since the first function is having x and the second function is also having a part of x, so here we will have to use product rule of differentiation. So we can take this as first function and the bracket as the second function. So according to the product rule, the first function is kept as it is, multiplied by the differentiation of the second function, plus the second function is kept as it is, multiplied by the differentiation of the first function. So this is the product rule for differentiation. Now we will differentiate 1 minus x by y with respect to x. So differentiation of 1 will become 0, minus here we are differentiating partially with respect to x. So 1 upon y is treated as constant, and differentiation of x with respect to x will be 1. So here we are getting 0 minus 1 upon y, plus 1 minus x by y will remain as it is, and we will differentiate e raised to the power x by y with respect to x, swallowed by the chain rule. So differentiation of an exponential function is the function itself multiplied by del x of x by y. So chain rule. Last step is you will have to simplify. So 0 minus 1 upon y will be minus 1 upon y e raised to the power x by y, plus here we can differentiate it first and then write it simultaneously. So differentiation of x by y with respect to x, so we will treat y as constant. So 1 upon y will be taken out of the calculation, and differentiation of x with respect to x will be 1. So finally we are left with 1 upon y e raised to the power x by y, minus the bracket will remain as it is. So here 1 upon y is taken out and differentiation of x with respect to x is 1. Now we can simplify. What we can do last is to simplify. So we will open this bracket. We will open this bracket, multiply the terms and simplify. So we will get the final value of del n by del x. So del n by del x is equal to, the first term will remain as it is, minus 1 upon y e raised to the power x by y, plus here we will multiply it by 1. So we will get plus 1 upon y e raised to the power x by y, minus of this y and y will get multiplied and we will have x by y square multiplied by e raised to the power x by y. So what you can see that the first and the second term are like terms of opposite sign. So finally del n upon del x is equal to minus x by y square multiplied by e raised to the power x by y, which is same as the value of del m by del y. See, del m by del y, we are having minus x by y square e raised to the power x by y. So both the derivatives are having the same value. So we can write clearly, we can see that del m by del y is equal to del n by del x. So this implies that equation 1 is exact differential equation. Now the last step is to find the solution of this exact differential equation. So we have a formula for this, that is solution of equation number 1 is given by integration m dx, where y is treated as constant, plus integration of n, where the terms are free from x, dy is equal to c. So, and here we treat x as constant. X is constant for the second integral. So now we will substitute the value of m, we will substitute the value of n. So m was e raised to the power x by y. We will have to go back to the question. M is 1 plus e raised to the power x by y, 1 plus e raised to the power x by y, integration y is treated as constant multiplied by dx, plus here x is treated as constant and we consider only the value of n which is free from x. So n is what? N, we can recall it here, the value of n was e raised to the power x by y multiplied by 1 minus x by y. So here you can see that even though if we multiply e raised to the power x by y within the bracket, there will be no term which will be free from x. So here there is no term which is free from x. So finally integration we will have to do with respect to x, this is x, okay. So integration of 1 and we have to treat y as constant. So integration of 1 dx treating y constant plus integration of e raised to the power x by y dx treating y constant is equal to c. So this was the value of integration, yes. So integration of 1 with respect to x, integration of 1 with respect to x is x plus integration of e raised to the power x by y. Since here we have a function of x, so we can easily integrate it and we will have e raised to the power x by y divided by the differentiation of the power, that is x by y is equal to c. So now we are having the final solution, that is x plus e raised to the power x by y divided by the differentiation of x by y with respect to x. So that is we will differentiate it partially with respect to, so here we will differentiate it partially with respect to x. So here we will have just 1 upon y, or so the final solution of the given differential equation is x plus y e raised to the power x by y, that is equal to c. So here since we are dealing with partial differentiation, so here we will partially differentiate the power x by y with respect to x. So 1 upon y is taken as constant and differentiation of x with respect to x is 1. So here in the denominator we are having 1 upon y, which can be reciprocated, and so the final solution is x plus y into e raised to the power x by y is equal to c. I hope this lecture is clear to you. The concept of exact differential equation and the condition of exactness, the method for solving the exact differential equation is almost clear to you. So that's all for this video. Thank you.